Okay, so welcome back to our series dedicated to solving CodeWars kata, and in this video we will be solving a kata level 6 called odd/even number of divisors. And it's pretty self-explanatory, given an input number n, we're supposed to decide if it has an odd or an even number of divisors. And it gives us a few examples. All the prime numbers have exactly 2 divisors, 1 in the number itself, therefore it's even. And for 12, it's going to be an even number of divisors, 1, 2, 3, 4, 6, 12. And for n equals 4, the divisors are 1, 2, 4 odd. And so what I think is really helpful here before even jumping in and trying to solve this, I think it's really important to run through some test cases. So just to sort of understand, I think it really gives away a big part of how to solve this problem really quickly and easily if you do this. So just starting from 1, 1 has 1 divisor, so it's going to be odd. So let's say odd is 1. And even will be 2, it's a prime number. 3 also, and then for odd back to, or 4 is back to odd. 5 again because it's prime. 6 because it is 1, 2, 3, 6, so that's 4. 7 because it's prime. 8 because it's even, because 1, 2, 4, 8 is 4 divisors. And then here back to 9 is odd. And so what you'll start to see here quickly is that the odd numbers are actually only the square roots. So again, 16, 25, 36, all those going up, up, up. And anything not a square root will have even number of divisors. So what this question is really asking is to just determine if the number is a square root or not. So that's kind of another way of thinking about that problem. And so the first way we're going to solve this problem is first we're going to import our math library just to allow us to use math.square root, which will make it really easy to determine if a number is a square root or not. So if math.square root, remember if you're ever using a library, you always have to use the name of the library and then dot the function that you're using. And we're checking if this is an integer. So we have a dot here and then is underscore integer, open close brackets. So if that's true, we want to return odd, because we'll have an odd number of divisors. And then if not, otherwise we want to return even. So we're going to go ahead and test that. You can see we passed all those cases, and now we're running through the big sample. We passed all 1500, awesome. And so there's actually a few different ways to kind of do an if statement here. So we're just going to kind of run through them really quickly because you don't actually have to use the math library, but it is fairly convenient and it's a good one to know, as is this dot is integer. So what we're doing here when we had the math library in here, we're taking the square root of n basically, and then checking if it was an integer. And so, for example, if the input n is 39, then the square root of 39 is not an integer, so this would not return odd. It wouldn't go at all. Instead, the else statement would hit, and then we would return even. So this is kind of a weird kind of solution because we are assuming that we're given all integers, although it doesn't actually state that. Actually, it does, given an integer n. So there you go. So we know that this will work for any integer n. Okay, but yeah, like I said, moving on. There's a few different ways you can do this without even using the math library. So the first way, we're just going to raise n to the power of 0.5 and then check if it's equal to the integer of the same thing. And so what this will do is, for example, if n is 13, we're going to say the square root of 13, is that equal to the integer conversion of the square root of 13? And the square root of 13 will have some decimal places, but when you convert it to the integer, we're going to be getting rid of all those decimal places. So for the example of the square root of 13, it's not going to be equal to each other. It's going to be 3.7. This will be around 3.7, and then this will be 4. And so obviously 3.7, blah, 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 all those integers is not equal to 4. So this will never hit, and instead we're going to return our even case. So just to show again, we're going to test it. Oh, looks like we forgot a semicolon. So we're going to go ahead and test that, attempt it, and you can see that we passed all those tests as well. And then the last way we're going to do it is sort of using the same idea of using star to raise to the power of. So what we're going to do is the same thing. We're going to take n to the 0.5, otherwise known as the square root of n, and then we're going to mod it by 1. And then if this is equal to 0, then we want to return odd again. And so what this will do is, for an example, let's say square root of 8, it's going to be around 2.8 something. 2.8, once you mod 1 it will give a remainder of 0.8, and 0.8 is not equal to 0. Like if you take the number 9, for example, square root of 9 is 3. 3, is divisible by 1 throughout. So 3 mod 1 is going to be 0. 0 equals 0. This odd statement will hit. But just to show you that this works, we're going to go ahead and run it and attempt that. And so yeah, that's pretty much it. Those are 3 kind of pretty common ways to do it and to solve this problem. So if you have any questions, or if you have any solutions that maybe I should go over instead of these 3, feel free to comment those down below. Thanks for watching. Bye.